Cool. Hello, everybody.
You should be good. Yep.
Okay, cool. Cool. Hi, I'm Ben Curry-Cox. This is BGP error handling, which is a sort of upgraded version of my blog post that you might have read. The first and most important mandatory, I suppose, I run a business which involves being peered to many IXP root servers and people's routers and stuff. I won't test exploits on them, I promise, unless you give consent to have your router target practiced. All testing in the post was done on VMs and physical hardware for the rare case for Juniper, where it's harder to emulate that stuff. Starting off, recently a Brazilian ASN started announcing a IPv6 route with an interesting BGP attribute. It was interesting because it basically killed every Juniper device that ingested it, which is cool. Of course, that's OK for peering to some degree. Like, if your peering sessions come down, like, it's not great. That's really less OK if it's a transit session, because that's potentially like going to disconnect you from the internet. The one interesting thing, the one that brought it to my attention, I know many different ASNs got impacted by this, but Colt, like British, like supercarrier, mostly British, I assume, basically got de-peered from the internet entirely. Other ASNs got hurt too, as mentioned, but Colt was the big one, and that's what actually drew my attention to it, because it inconvenienced me. So the offending payload on this packet was extremely boring. Basically, it's attribute 28, BGP entropy label capability. Looking at the RFC, it's interesting. It's effectively, I assume this was originated from a Huawei device, and somehow like an iBGP attribute got regurgitated back straight out onto the internet. This attribute is technically not corrupted. It's, as one would expect, like a BGP entropy label capability attribute to look like. But however, just this presence of here and it interacting with a Junos version of around 17 and above, I don't have all the versions, so I can't do a binary search on the exact vulnerable version. But around 17 plus-ish would basically blow up the session, which is bad. So BGP attributes. There are two sections of a BGP attribute. There's the NRI and the withdraw data, aka basically what prefixes you're dealing with. And then there is the attributes. In BGP multiproto, those things are also in the attributes, but that's a detail that it's not worth thinking about. So attributes contain useful stuff like the AS path, your community values, local pref if you're iBGP, med if you're on eBGP and you care about med, aggregation info, stuff like that, stuff to describe a route. There are a lot of attributes out there. There's about 200, the 209 are technically unassigned, so up for grabs if you are willing to work with the IANA. 14 are deprecated. 32 are active. And that basically just means that there's no formal definition for them being not used anymore. Most of these, however, like still, even the active ones are not actually used anymore, or increasingly rare or only used in iBGP environments. A very, very vanishingly small amount of these attributes you'll actually see on the real internet that you would get from like a transit provider. But you know, what about the ones that are technically deprecated? What about the ones that like you wouldn't normally see over a transit session? They surely must be handled all correctly, right? So, picture this. You're on a friendly internet exchange, everyone's nice and happy, and they're all connected to the root server. And then someone goes, hey guys, check out this really cool BGP attribute I found. And some people get blown up. Basically what ends up happening is, upon receiving the attribute, the people who are vulnerable to the session on the other side will basically go, I don't know what that is, and immediately like reconnect the session. Just disconnect it down and probably reconnect. So this is pretty bad. Losing root servers is a fantastic way of shifting a large amount of traffic for a large amount of networks. This is bad, but the really bad one is this sort of scenario, in where, you know, once again, hey guys, check out this cool attribute I found. And where you can target specific devices, because not all of the operating system vendors are vulnerable to the same things. So you can effectively skip vulnerabilities across the internet and have them target the device that you're looking for. So for example, if in this hypothetical situation, where you know NTT runs Junos, Cogent runs iOS, and then you are running Extreme, then you basically can get blown up because you can send an attribute out through NTT, which will get carried to Cogent, and regardless, both of your sessions will explode, because Cogent will happily carry an attribute that it doesn't understand. Funnily enough, in RFC 7606, which is one of the RFCs that if your vendor implements correctly should mitigate all of the problems I'm about to describe to you, has a securities consideration section that I can best describe as bang on the money. RFC's security consideration sections have always, in my eyes, not been massively helpful. However, this one perfectly describes the situation that I found myself in. I won't read the entire thing to you, but I will basically read out the bit that made me laugh when I read it for the first time. Since significant fan-out can occur between the attacker and the routers that do recognize the attribute type, this attack could be potentially particularly harmful. That's pretty correct. It can be particularly harmful. So how do you find all these problems? So first, you're going to basically build a fuzzer. A fuzzer is a type of security program that basically cycles through as much random data as possible to try and highlight as many different code paths. And the idea is that the more code paths you highlight, the more broken stuff you're inevitably going to find. The way this particular fuzzer works, basically I just custom built a script which goes through all of the BGP attribute types and just fills those attributes between 0 and a random number of bytes. Hoping that at some point some device will pick it up and be like, oh, I'm going to try and decode that, and then potentially explode while they do. This is fine and all. However, what I also want to check is whether it has a internet bullet status, and that basically is defined as something that you can actually worm across the internet, because you can peer-to-peer, you can blow up any session you want. You can just send random data, and yeah, sure, the session is probably going to shut down. The really interesting / terrifying stuff is something that you can give to someone and unknowingly they would pass around the world to pass to their peers, which then causes bad things to happen to people onwards. That's the really interesting stuff. And so that's what I was looking for. So to do that, I basically used Bird2 as a sort of filter for the stuff that clearly wasn't achievable, or just stuff that you couldn't worm, because Bird handles a lot of bad attributes very well. RFC 7606 compatible, and so I might as well go and use that. So all of the stuff went through Bird before it got handled to the target vendor being tested. And to clarify, the way the fuzzer works is it can run unattended, so it means I can just spend most of the time setting up a router vendor, and then just turn the fuzzer on, go and do something, make a cup of tea or whatever, and then check back later to see if the sessions have exploded. The way it knows whether the session has exploded, given it's not directly connected, is that the victim router announces a IP block that it monitors, and if the block is withdrawn, then it knows that it just sent something that killed the other side. In which case, it'll then withdraw the dodgy attribute, or the dodgy announcement, wait for the other side to come back up, and continue fuzzing onwards. This is roughly what it looks like. So you run the program, it connects to the first hop, and then on the Bird side, you can see it announcing the highlighted bit, the bgp.ec. EC is the hex code for the type, and then the contents in there is the random bytes that the fuzzer generated. So how did we do on this fuzzer? So surprisingly, MikroTik, no issues. Didn't log a single error. This is also router OS 7.7. Obviously, router OS is slightly infamous for having different behavior version to version, even the minor releases. So unknowing if anyone in the room is actually using 7.7 in particular, but if you are using 7.7 in particular, then you're actually safe. Ubiquity, also, to me, surprisingly, which will become clear later, no problem. No issues detected. I suspect the Edge OS devices forked off Quagga a long time ago before Quagga and then FRR grew any of the features that would soon to become problematic. So yeah, I thought that was very interesting. Arista EOS, at least the versions I tested, no problems. Didn't log anything, although then again, I'm not a deeply experienced with EOS, so it could be logging it to a place that I never found. But I did do a good look, and I couldn't find any errors, any error logs, which would be helpful. Because it's useful to know when you encounter something on RFC 7606 that handles, basically if that RFC handles a bad attribute, the old behavior was to blow up the BGP session. The new behavior is to turn it into a withdraw. So it would be nice to know if that behavior has been triggered. iOS XE, XR, and Classic. Also, no errors. They log the issue perhaps a little bit too verbosely, to the point where if you're logged in on the serial console and you're getting slammed with this stuff, your serial console will also be getting slammed with this stuff. That's slightly annoying, but also it is what it is. It's better than nothing. You can turn off all of the messages if you want, but once again, it'll be nice to know. Junos. So we know about attribute 28 already because that's the one that started this entire adventure. It turns out attribute 29, one up, also has a similar problem. I say not disclosed publicly, that's an old slide. It is disclosed publicly, as you see, as seen in JSA 75210. Basically, similar thing, corrupted attribute causes thing to explode. So you can mitigate this, and you should mitigate this by going into your Junos config and adding BGP-error-tolerance. You can enable this without any downsides. So it will instantly activate the new behavior. It won't reset any of your sessions. I don't think there is any downside to adding this. So please, for the love of God, add this. There is no reason to not, in my eyes. And Nokia SROS, there are loads of ways to pop a Nokia SROS session. I won't describe them all, but some of them overlap with Junos. Nokia also has a way of handling this correctly. It is also not default, so you have to add that there. Basically, you go into your BGP groups and type error handling update fault tolerance. That then makes it work correctly. Because I think that this one was particularly obscure, people were already stung by the Juniper issues, but the Nokia stuff hadn't seemed to have been impacted by any of these problems just yet, probably because the attributes required here are slightly obscure, and so just had a very low chance of actually appearing on the internet. So I viewed Nokia when I was researching this as sort of like a high risk, because I suspect no one had actually, I suspected and was actually reasonably correct in the end, that almost no one had actually activated error handling update fault tolerance on their SROS boxes. I would like to thank the following people. Okay, I redacted a few. I would like also to thank the people who probably know that I notified them for enabling it. Me contacting them and be like, hey, are you aware that your router, your edge could be exploded? They generally took the message well. So yeah, thank you to those people for doing that. It's also worth pointing out that Nokia has released a statement or a bug issue thing under 230450B. You can only view that if you're logged in to the Nokia alerts portal, but if you are a Nokia customer, then you can view that. It basically says everything I just said. Huawei Net Engine, no issues detected, which I think is very, it surprised me at least. I was expecting something from that platform. But also, finding Huawei images are extremely difficult due to the nature of sometimes import restrictions, things like that. I can't even acquire like test hardware, which makes it very hard to actually just get a physical box off eBay and test it. So there may be bugs in other products, but I couldn't find anyone in this particular product. FRR had a very similar issue. If you sent a corrupted tunnel encapsulation, which you can send regardless of whether it's an IBGP session or not, the session would explode. It was assigned to CV, and it was fixed post-public disclosure, is what it is. Was a little bit annoying to have to go through public disclosure and then have FRR fix that problem, but open source. OpenBGPD, which was surprising to me, exploded on an invalid origin to customer, only to customer. Handles the behavior correctly with all the other packets. It's actually turned out to be a much more interesting bug in the OpenBGPD that seemed to only be reachable with this type of attribute. This was fixed in OpenBSD, signed to CSV, CVE, whatever. Extreme. So Extreme explodes on two attributes. Both are pretty obscure, and actually the problem here is that if your attribute is obscure, you have a higher chance of it being exploitable, because as per the rules of BGP propagation on unknown attributes, if your router understands the attribute, then it may handle things, it may apply RFC 7606 processing to it. If it doesn't understand the attribute and the transitive bit is set, then that's going to go across all around the internet until it hits the target device that does understand it, or understands it. And so that's really bad. So if your thing explodes on an obscure attribute, that's really bad, because that allows you to target extreme devices in particular. What's also very bad is after contacting Extreme about this, there is no mitigating config by default, and Extreme does not want to patch this. Their argument is that the RFC, the original BGP RFC, declares that you should explode in these situations, and therefore they will explode in this situation. That's a bit further on this, but basically there's a CVE assigned for this. It's currently being disputed by Extreme, whatever. So this is an email that I exchanged, the final email exchange I had with Extreme. I won't read the entire thing to you, but I will read my favorite bits of the highlights. We are not considering this a vulnerability due to the presence of RFC 7606. We are evaluating support for RFC 7606 as a future feature. There are some nuance in the middle, but this is one of the strangest security discussions I've had. So extremely strange that I would really recommend you actually read the entire email exchange, which I've posted and mostly redacted the names out of, just because I wouldn't believe if I said that to me in the future, in the past or whatever. So I reckon you should look at that exchange. It's very strange. yeah, to clarify what Extreme is saying, to clarify what this is, any AS can emit a BGP message with a corrupted v6 extended community attribute, a v6 address specific extended community attribute. It will get carried around a bunch of global networks, and when an Extreme device ingests it, it will reset the session. Now, because it's going to be propagated globally, that's going to be your transit session. That's going to cause your transit session to flap. That's going to be bad. Even better, though, it's going to flap over and over again, because when it reconnects to do a feed, it's going to ingest the same poison pill and then reset again. Not great. Actually, the better part about this is that if you are running, this doesn't even impact your edge devices. If you're running Extreme in your cores, then if it's got a full IBGP session, it's going to ingest that inside your core, which may be even worse of a place for it to do, because that might be a place where you have even less redundancy. So having that device go offline, as far as routing is concerned, could be even more catastrophic to your network. So yeah, thanks, Extreme. I don't, yeah. Here's my rough review of the security responses. You know, both of the open source vendor did a very decent job. My only slight regret is telling them a little bit too early on. I felt slightly pressured to allow OpenBSD to release a disclosure publicly a little bit too soon than I wanted to, but I've later been told on that OpenBSD is much more willing to handle coordinated disclosure in the future. I just didn't feel like it was that way when I talked to them for the first time. Juniper, they replied, they eventually pushed out a Junos patch. They didn't commit to enabling this behavior to be safe by default. They haven't committed to that. Nokia replied, and later has confirmed to me in the last few days that from March 2024, SROS versions will ship with this default safe behavior. They eventually did custom communication. I have a feeling they only started doing customer communication after I started going after their customers, because I was worried about the risk. So yeah, not so great that needed to happen. FRR, when I emailed them, very quick reply, acknowledged the issues, and then disappeared completely. No email replies after that, and then only patched after public disclosure. And Extreme, well, you saw the Extreme. Yeah. Most importantly, or at least to me, none of these vendors have any bug bounty program. So kind of reporting this was a giant waste of my time. You know, I would, in a normal situation, had this not been potentially internet bricking, I would have just sat on this and sort of put this in the filing cabinet, being like, oh yeah, cool, there's a small nuclear weapon in my home directory, because this took a long time to deal with. Like dealing with these vendors, sometimes it was frustrating for some of the vendors to be like, you know, reminder, like I'm not paid to report this to you, and you know you're asking some sometimes very tedious questions, or alternatively forcing me to argue my point of the risk. You know, sometimes I now have to go, in the case of Nokia especially, like I now have to go, and Extreme to some degree, I now have to go to your customers and be like, hey, over IRC, do you have this option set? Because if you don't, that might be bad news. I shouldn't need to do that. You know who your customers are. Please tell them that there are problems. So that's very frustrating. There's no bug bounty program. I find it kind of shocking that the internet is increasingly important to everyday life, and these vendors don't seem to have a high bar for, or at least a modern view of security handling processes. Of course, it's worth pointing out that there's a second newer level, there's an A+ on the security response. It's for the people who didn't have the bug in the first place. So I never thought that Microtik would get an A+ here, but you know, it's fine. Credit where credit's due, they did the right thing, so good for them. Are there any questions?
Hi, Sander Stefan, Juniper customer and consultant to Juniper customers. To the Juniper people in the room, Melchior, could you please ask them to make the safe behavior the default? Thanks.
Yeah, I mean, honestly though, like in all seriousness, it would be really useful if vendors did. I understand the vendor's point of view around default changing. It's potentially terrifying. Go for it.
Hello, Melchior from Juniper.
Hello.
I'm more than happy to discuss it. I don't know. I trust that you say that it doesn't have any other impact, but I will discuss it with our BGP coders team.
It's a case of like I understand from the Juniper's point of view, I understand the hesitancy. Changing a default on platforms that have held strong defaults for the last 10, 20 years is a very scary thing. However, also the internet is kind of real now and does pretty pretty important things. You should be able to change defaults when it's of sort of critical security to do so.
Agree. Yeah.
Thanks.
There we go, solved.
Joris, yeah?
Hi, yeah, Joris from Arista here. So I just wanted to add that there are indeed show commands to show the BGP update errors.
Ah, okay, cool.
I've dropped them in the IRC. And there should also be some logging, but well. If
yeah, I might honestly for the VEOS stuff, I might have honestly missed where it was going. So
right, okay.
Any other questions? Yeah. Good. Make your way to the microphone.
I know the person asking this is here, but was Brocade MLX or SLX tested as well? Since you mentioned.
Sorry, say again.
The Brocade MLX or SLX.
I don't have a Brocade MLX to test, and I don't have virtual platforms, which, given that the average size of a Brocade is huge, I didn't want to lug that into my living room.
Okay, thanks.
Also, power is expensive. We're in Europe.
Hi. Do you have any experience or thoughts of applying filtering onto the attributes?
So that's an interesting point. So when I explain this to someone, they're like, "Oh, that's fine because like surely if I filter these routes, there's no problem." There's two problems with that. One is that almost all, I think, in fact, actually, I'm pretty confident to say all of these bugs happen pre-filter step because it's happening when the BGP daemon is parsing out the BGP update, and so you can't really filter these out. However, there are hidden options on certain platforms. I think Juniper has one, and I think Cisco has one as well. Don't know which flavor of Cisco, where you can drop a list of certain attributes. And so there's a whole bunch of, I know a bunch of tier 1-ish carriers who are dropping certain attributes inside their cores to stop propagation of certain bugs. Okay. But I don't know if it's fair to disclose which ones are doing that and what attributes they're doing. But yes, there are technically hidden functionalities to do this. I think.
So since you have a reach to the lot of vendors here, how would you recommend to them to implement the bug bounty programs?
I mean, I'm not the right person to ask, but I don't know. Like, there are platforms like HackerOne. I don't know if they're any good, but like, yeah, I am. As I said, I'm not I am the BGP tools guy. I'm not a network person, or I'm not a security person, at least. So I don't know the actual decent answer to that. I'll happily let that to someone who actually understands how bug bounties are supposed to work.
Hi, Will Hargrave from Lonat. Sorry, this microphone's configured for Dutch people. I'll stand on tiptoe. So to be clear, as a set of recommendation to vendors, I think what you're saying here is the gold standard is RFC 7606, treat as withdraw for bad attributes, and that's what you would like vendors to have that turned on by default. Yep. The kind of silver standard is yes, at least we have a knob so that people can turn this on, and the poo standard is we don't have any support.
Yeah,
for
we don't think that
withdraw.
the bug is real.
Okay. Yeah, that's the kind of useful key thing I think that I'd like to see as perhaps a closing slide there on your presentation, because it says what pressure we should apply to vendors to look after the internet better.
I mean, sure, but on getting back to that though, the response also matters on like the quality of reply, right? Like if this, once again, had this not been completely internet breaking and I had reported it, I would have probably given up. I'd just be like, you know what, guys, whatever, do what you want, because actually I'm just going to keep this in my drawer and you do whatever you want with it. In fact, for at least one of these vendors, there is a further on bug that I just don't care enough to report anymore. Because, like, why would I? Like, if they were relatively, like, unhelpful in the first place, why would I report more to you again?
The absolute shocking thing for me is that actually I worked on a bug like this in, 2009, I think, with confederations, and that's what led to that treat as withdraw behavior, and it's like, that was a long time ago now. I look at mailing list posts and it says, 15 years ago I posted something. What?
No, and there was a previous one in like the 2000s when, early 2000, maybe this is the 2009 one, where Wright published a route with like attribute 255, which caused a bunch of Ciscos to explode. So, you know, this is not a new bug by any means. I think what's interesting here is that I sat down and was like, okay, let's do a like comprehensive test on every single major platform, in my eyes at least, ones that people are using, at least at the edges. And it turns out there's still broken stuff.
Yes, thank you for doing that.
Thank you all for your questions. Thank you, Ben. I have one more question myself about the reporting of the issue. You wrote in your blog that it was very hard to get in touch with the vendors, basically because you were not a customer of them.
Yes.
I can imagine that there would be people in this room who would be able to help you with this sort of thing in future.
So it turns out when you blog about something like that, your inbox suddenly becomes flooded with lots of really interesting people at vendors who are like, I'm really sorry about that. You can just email me personally next time. I'm actually set for that now.
Perfect, thank you. We have a small present for you, which I'm sure you'll like.